Let us look at the next section now, students. This section contains two matrix match the column types questions, in which we have to match entries given in column 1 to the entries given in column 2, and the options given in column 1 may have one or more than one matching to options given in column 2. So let us start with question number 36. Consider a specific acid catalyzed reaction S plus H plus giving us P plus S plus. So S plus is acting as a catalyst and it is remaining unaffected during the course of the reaction. And specific base catalyzed reaction, similarly, the H plus has been replaced by the OH minus. For example, a specific base catalyzed reaction, the rate of reaction, which is minus ds by dt, it can be written as K into concentration of S, which was the reactant or the substrate, into the concentration of OH minus. So we're talking about the specific base catalyzed reaction in this case. The examiner further mentions to us that K apparent is the overall rate constant of a specific catalyzed reaction. So column 1 consists of some graphs which are showing the variation of rate with pH and rate equations and rate constants in column 2. So let us look at the entries given in column 2 first. So we can see that the option P is for a base catalyzed reaction, whereas the option Q is for a acid catalyzed reaction, as there is an H plus term in the expression given in Q. Now if we look further, in the option R, the examiner is again interested in the acid catalyzed, whereas if we look at options S and T, we can see that the examiner is now talking about the base catalyzed reaction, as concentration of OH minus can be written as the Kw of water upon concentration of H plus. So students, we can clearly see that P, S and T options will always be clubbed together, as they all deal with the base catalyzed reaction, and options Q and R will be clubbed together as they are dealing with the acid catalyzed reaction. So let us try and solve these expressions. So let's start with the acid catalyzed first. So the examiner is interested in knowing about the variation of K apparent with the pH and log K apparent with the pH. So let's start with the acid catalyzed reaction first. So we have minus ds by dt, which is the rate of reaction. It is equal to K into concentration of H plus into concentration of S. So this value written under brackets is the K apparent value. So we have K apparent equal to K into H plus ion concentration. So if we take log both sides, we have log of K apparent equal to log K plus log of H plus ion concentration. Now students, the examiner is interested in the pH value. So we can probably convert this term into minus pH. So the log H value can be written as minus of pH. So this expression will simplify to log K apparent equal to log K minus pH. If we try and figure out the type of curve represented by this equation, we have log K apparent in the y-axis, we have pH in the x-axis. So this is of the form y equal to mx plus c, where m is equal to minus 1 and the intercept value, which is represented by c, is given by log of K. So we can see that the diagram which was for the acid catalyzed reaction is given correctly in option A. So option A will be matched with all of the options which correspond to acid catalyzed. So A will be matched with Q and R. Similarly, if we do similar calculations as we had done in the acid catalyzed reaction, we could do similar calculations for the base catalyzed reaction, and we can find out that the graph given in option B will correspond to the base catalyzed reaction. So students, the option B will be matched with P, S and T. So we had already seen that P, S and T all talk about the base catalyzed reaction simultaneously. Let us look at option C now. For option C and option D, it is quite easy. So we just have to comment on the variation of K apparent with the pH value. So it is seen that in option C, when the pH value increases, the K apparent value decreases. So it means that the H plus ion concentration is decreasing, which is causing the K of the reaction to also decrease. It must mean that this curve represents an acid catalyzed reaction, and so it has to be matched with Q and R as well. At the curve given in option D now, we see that due to increase in pH, the apparent rate constant of the reaction also increases. It must mean that as the concentration of OH minus increases, the pH increases and the rate of reaction also increases. So this curve represents a base catalyzed reaction. And like the previous option, we can see that this will be matched with PS and T. So students, we have the correct match for question number 36. Let us look at the next question now. Question 37. So column 1 has some reactions and column 2 has some statements which belong to those reactions. So we have Ag2O and Hg2O which are dissolved in NaOH and ammonia. And we also have NiOH whole twice and CrOH whole thrice which are also dissolved in NaOH and ammonia. So we can probably figure out the reactions first and then look at the matchings later. So Ag2O. Ag2O, when it is allowed to dissolve in OH minus excess, it does not dissolve. Whereas Ag2O or the Ag plus ions present in Ag2O, it has a good affinity for ammonia and it dissolves, forming AgNH3 whole twice complex. If we look at Hg2O now, Hg2O is insoluble in both OH minus as well as ammonia, even when both of them are in excess. So Hg2O does not dissolve. Let us look at the hydroxides now. We have NiOH whole twice. So it does not dissolve in excess of hydroxide ions. Whereas when it is allowed to react with excess of ammonia, it dissolves owing to the complexation reaction. So we have NiNH3 whole 6, 2 positive. If we look at the last species present, which is CrOH whole thrice, so it dissolves in OH minus excess to form CrOH whole 4 negative. It forms a 4 coordinated complex, whereas it does not react with excess ammonia. So the examiner is also interested in the coloration. So we have CrOH whole 4 minus, which is green in color. We have NiNH3 whole 6 twice, which is blue in color. And we have the formation of diamine silver complex, which is colorless. So let us look at the options now. So option A, Ag2O and Hg2O in excess NaOH. Students, we had already seen that both of them do not dissolve. So it has to be matched with option R. Let us look at the option B now. Ag2O and Hg2O, they are allowed to react with excess of ammonia. So we had seen that only Ag2O dissolves in excess ammonia owing to the complexation of Ag plus ions with ammonia ligand. So only one of them is completely soluble. So it has to be matched with option Q. And as far as the color is concerned, the color of the solution will be colorless. Both of these statements will not be matched with option B. If you look at option C now, so we have NiOH whole twice and CrOH whole thrice dissolving in excess of NaOH. So NiOH whole twice is not going to dissolve, whereas CrOH whole thrice will dissolve owing to the complexation. So it will form CrOH whole 4 minus. So one of them is completely soluble. So Q will be a match, and one of the reactant will produce a green solution. So it will also be matched with S. So option C will be matched with Q and S. Let us look at option D now. We have NiOH whole twice and CrOH whole thrice, which is dissolving in excess of ammonia. So in this case, only the nickel plus 2 will form a complex with ammonia, which will lead to the formation of a deep blue solution. So only one of them is completely soluble. So it will be matched with Q and it will be matched with T. So students, this is the correct match for this question.